In this lecture, we will talk a little bit about the database landscape and dive deep into relational databases and how they work.
And once we have that information, we will then take this and understand the syntax and how to get all of that data goodness out of your database.
A database management system is a software which controls the storage, retrieval, deletion, security, and integrity of data within a database. Databases can be categorized into out-of-memory tables, relational databases, and NoSQL databases. Out-of-memory tables provide access to tables that are too big to store in memory. Relational databases store data in collections of tables, and NoSQL stores data in other unstructured ways, such as dictionaries or document structured. In this tutorial, we will focus on relational databases. In a relational database, data is stored in tables. The tables are made up of rows and columns. Each table will contain at least one column containing keys or IDs. These keys correspond to keys in other tables. Keys are essential to making a database relational. Each table has a unique identifier which corresponds to the row in the table. These unique identifiers allow us to match that data in one table to data in another table. For example, if we wanted to look up the shipping address of a particular order from the sales table, we would look up the corresponding customer ID in the customer table. Similarly, if we wanted to see whether any items from a sales order have been returned, we can look up the unique order ID from the sales table in the returns table to see which products and for what reason the items were returned. In general, keys belong to two categories, primary and foreign. Primary keys uniquely identify each row in a table, whereas foreign keys refer to a primary key in another table but do not uniquely identify each row in a table. That is, the foreign key can appear multiple times in a table. This model of tables and keys is known as an entity relationship model. The entities refer to the keys that link two or more tables. In some cases, the entity may be unique, as with a primary key, and in other cases, the entity may appear multiple times, as with a foreign key. If the key is a unique identifier for both tables, it is called a one-to-one relationship. If the key is unique in one table and not in the other, then it is referred to a one-to-many relationship. For example, imagine you place an order for basic household items from Amazon, such things as paper towels, garbage bags, batteries. Your order would show up as a single order entry in the sales table, but it would have 3 entries in the products table. In this case, the relationship between sales and products for that order would have a one-to-many relationship. It is important to stay mindful of many-to-many relationships and to avoid them if possible. In a relational database, data is stored in tables. These tables are usually grouped as facts and dimensions. Facts contain the business facts and measures such as revenue, cost of goods sold, or units sold. The raw data for these facts may be stored in tables but are not always made visible due to security. On the other hand, dimension tables contain descriptive attributes such as a customer's profile information or product information. A database schema is a skeleton structure that represents the logical view of the entire database. It defines how the data is organized and how the relations among them are associated. On this slide, we show the most basic schema, a star schema. As shown, the center of the star is the facts table, sales. It is a facts table because it contains aggregates and calculations of the dimensions. The keys in this table connect the facts table to the input dimensional tables. It is a star schema due to its shape. The next progression of a schema is the snowflake. That is, we still have the facts table at the center, which connect to the dimension tables, but those dimensional tables can be further broken down into further dimensions. For example, the order ID in the sales table also appears in the products table. By looking up the order ID in the products table, we can see the list of products that were included in the order. Yet, our hypothetical company may also collect specific product information such as supplier and commodity group, which are grouped into separate dimension tables. In this example, if you wanted to obtain the supplier information of a product from a single sales order, you would need to reference all 3 tables, sales, products, and supplier. To write a query, it is important to know basic operations of a relational database. One easy way to remember this is by the acronym CRUD. That is create, read, update, and delete. Create stands for creating new tables or creating new entries in a database. Read stands for reading the data, so extracting the information in the database. Update means updating entries in database or updating a table. And delete means removing or deleting erroneous or irrelevant data.
So now that we have an understanding of how relational databases work and what they are, we can begin to understand how we can take data from them. So, a select statement. A select statement allows you to select specific data from a specific table. And you do that using the select, then insert your columns, and then say from table name. Please note that you always end your queries with a semicolon. So let's look at an example. You should already have set up the movies database as we went through in a previous video. If you've not, I would stop here, go back, put it together, and then come back so then you can play along as we code. So, the select term. The select term is known as a verb. You would then go select star. Star is a wildcard entry, which means select everything from movies. And please note again, the semicolon. And as you can see, we get the movie ID, the movie title, the year, and any genres associated with that particular movie. So now it's your turn to get your hands on the keyboard. What is the syntax for selecting all of the data in the ratings table? Pause the video here, have a go, and when you're ready, press play. Right, now that you've had a chance to think about it, how would you go about doing this? Well, you want to do select star from ratings. And what you get out is the user ID, which is the ID of the user who rated that movie, the movie ID corresponding to a unique movie. You've got rating, what that movie was rated, and a timestamp. Now, you will, of course, need to filter your data. You never want to select all of it. So we can do that using the where clause. And the way to do that is to go select column from table where condition. And then you can also order that output by using the order by clause. Now, by default, order by sorts your data in ascending order. I leave it as an exercise for you to try and find out how to make it descending order. So, here we go. Your turn again. Let's use the where and order by clause to find movies that were released between 2001 and 2003. Pause the video here, give it a go, and when you're ready, press play. Well, the way to do this is you go select star from movies where year is greater than or equal to 2001 and less than or equal to 2003. And again, we will order by the year. And there we go. That's exactly what we wanted. Now, as I mentioned earlier, you don't always want to select all of your data. But sometimes you will have to write scripts that query small fractions of that data. Well, you can create those small fractions of data into subtables. Those are called views. And it allows you to query the relevant data very quickly, and it's a lot easier than having a whole bunch of subqueries in one big script. Let's take an example. Let's say you're a data scientist at Amazon, and you want to know everybody who's bought stuff from the sports department. Rather than having to query, select all the data and then filtering on sports every single time, create a view. And then that view can be used to query further forward. As we mentioned earlier, the nice thing about relational databases is that you can join them together. So let's take two tables, X and Y. In X, the keys are 1, 2, and 3, and in Y, it's 1, 2, and 4. The data, X1, X2, X3, and Y1, Y2, and Y3. Now, if you want to take the data that is common to both tables, you're going to join on the key, and in this case, the common keys are 1 and 2. So what you can see is the inner join will give you only 1 and 2 and their respective values. If you do a left join, you're going to take all of the data from the left table, which is the first table, and only the corresponding data in the second table, or the right table. And as you can see, we get keys 1, 2, and 3, and we get an NA from a value of key 3 in table Y. And the opposite is true for a right join. We take all of the data from the second table, or the right table, and only the corresponding data in the left table. So as you can see, again, we have an NA in key 4 for table X. So let's see this in action. Let's say you want to select only the funny and scary or just the funny movies. I'm not a fan of scary movies on their own. I get scared really easily. So what you can see here is I've created two views, comedies and horrors, which contain movies that are comedies and movies that are horrors. And then you do your select statement and you select the headings that you want, the columns that you want. But notice how I've said, in keeping with SQL formats, I've gone comedies as C, and then I just do C dot column name. And I've done the same for horrors. And also notice that I've done a group by to ensure that I don't get any duplicates in my data. And I've also gone by column number, rather than having to type out the whole thing. And as you can see, we get what we want. Movies that are funny alone, funny and a little bit scary, but not scary alone. Superb. Now a right join. So this is going to find all the movies that are scary, scary and funny, but not just funny. So this is something Lillian might like. So we've done exactly the same thing, we've just changed it to a right join. And what we get out is probably all the movies that Lillian has watched on her Netflix account. You'll go, how do we use an inner join to find the movies that are both scary and funny? Pause the video here, write the code, come back when you're ready. Welcome back. So now you've had a go, how did you do it? Well, this is how I did it. I did an inner join on the horrors and comedies table. So here we're going to get all the movies that are scary and funny. And there we go, what we were looking for. Now, let's say you work in a very large company. You have all of this data stored in multiple databases. All of these databases are stored in what you call a data warehouse. Now, no, you do not want all of your company to have access to all of the data. This is for security purposes and to ensure that data doesn't get deleted by mistake. So the way you do this is you put the tables that the databases, that you care about into what are called data marts. These are subsets of data that only certain people can access. So in this case, we have 3 data marts that contain different data.
Finally, I'm going to provide you with my top 3 tips for writing effective SQL queries. Number 1, avoid querying the entire table. The database contains all the historical transactions of the company. That means that some of these tables contain millions of records. Hence, querying the entire table taxes database resources in querying a lot of unnecessary data and storing that in memory. To avoid doing this, think about what data that you need for your output. Then, try using a where clause or selecting only the necessary columns. Ideally, use a combination of column selection and where clause filtering. Finally, if you just want to sample the tables to see their contents, use limit at the end of your query to only display a limited amount of records. Tip number 2, avoid using like functions in the where clause. In this example of a like function, we are using a wildcard. That is, this query is searching for any product that contains the word blue. The percentage signs on either side means that we expect text on either side of the word. Queries like this do not use a table's index and will be very slow. In this case, consider the desired output. Are there other ways to filter by blue? Try first filtering by a date or ID and then filtering the result by the desired search term. Also, try narrowing the search by only looking for products that begin with the word blue. Finally, tip number 3, avoid joining entire tables. This tip is similar to tip number 1. By joining an entire table, you are implicitly doing a select all from. As I mentioned before, these tables can be very large. So querying an entire table is unnecessarily cumbersome and slow. Try instead to join only the necessary fields from the table and filtering out any unnecessary records, such as records that are more than 1 year old.
So thank you guys so much for joining us. Now go play with the data that we've given you and do your own queries and answer the questions. We hope you've had a lovely time and we cannot wait to see you on S2DS.